fairly large test. There's like 31 questions to it. Okay, but it's everything that we've done so far. So we start out with day one, coterminal angles are how many degrees apart? 360. So what do you do with the 242? Add 360 to do it. So if we add 360, we get 602, right? And then the negative coterminal, what do we do with 242? Minus 360, and I don't know what that is. Like, I don't know. Negative what? Negative 118. Thank you. Now, our 51 and 591 coterminal. 51 and 591, would they be coterminal? No, they have to be 360 apart. Those are like 540 apart. So no, they're not coterminal. They're either 360 apart or a multiple of 360. So if they're 720 apart, then they're coterminal. Okay. 283. What quadrant's that in? Well, you can, now that you have your unit circle, you can just look at your unit circle, but you wouldn't even have to look at your unit circle because that's in quadrant number 4. All right. How do you change from degrees, minutes, seconds to decimals? Do you multiply or divide by 60? Divide by 60. 18 divided by 60. 18 divided by 60 gives us 0.3. So this is 84 degrees, 50.3 minutes. Okay, and then we divide this by 60, and it's 84 to 4 decimal places. What would we have? Three. Now can't be 0.333. 8383. Okay. All right. 28.7 degrees is 28 degrees, and then 0.7 times 60 is exactly 42, right? So 42 minutes and 0 seconds. Okay. But if you get a decimal on this, then you take the 42, stick it in there, and take the decimal times 60 again. All right. 300 degrees to radian measure. To get to radian measure, we multiply by? No. Well, you could multiply by 2 pi, but I would just multiply 1 pi over 180. Divide them both by 10. 30 over 18 is the same as 6 goes into each. So 5 and 3. So 5 pi over 3. What else could you do for this problem if you didn't know what to do? Look at your unit circle. If you look at your unit circle at 300 degrees, do you have 5 pi over 3 sitting right there? Oh, look at that. 5 pi over 4. Again, you have your unit circle. You didn't when you first learned how to do this, but you do now. What is 5 pi over 4? 225 degrees. If you didn't know what to do, or if you didn't have your unit circle on you, multiply by 180 over pi is the basics of how to do that. All right. This is one that just stumps some people, and it really shouldn't. Because we're going coterminal angles, but with radians now. Okay? Pi over 5. Well, we want to add on to that 2 pi, which is 10 pi over 5. So if we add on 10 pi over 5, we get 11 pi over 5. If we add on another 10 pi over 5, we get 21 pi over 5. Which one has both 11 pi and 21 pi over 5? Well, choice C does. Now, some people see 11 pi over 5 and then just pick choice B. Sorry. 6 pi over 5 isn't coterminal with it. The angle in standard position, where is 7 pi over 6? Well, it's this one because we're going around this direction. It's not this one because that would be a negative 5 pi over 6. That one would be. Okay? Now, arc length. Arc length formula is on the board. Okay? Arc length S equals the alpha times R, which is pi over 2 times 32, which is 16 pi. Sector of the circle. Sector area of a circle, area equals alpha R squared divided by 2, right? So alpha is pi over 6 times 24 squared divided by 2. Well, 24 squared is 576. 576 goes into 6 quite a few times. Goes into 2 a few times. So do we end up with 48 pi? Okay. Canceling units. Okay, we have to know how to cancel units properly. Radians cancel with radians. Minutes cancel with minutes. I end up with revolutions per hour. And 10 times 60 is 600. Divided by 2 is 300 divided by pi. Now, don't take on your calculator 300 divided by 2 pi, because that would give you like 450 something. Okay? 300 divided by 2 is 150. And then you divide that by pi, which is like 40 something. 40 what? What? Oh, 600 divided by 2 divided by. Yep. Should be 600. I started dividing by 2 way too early. All right. So 600 divided by 2 pi, which is 300 divided by pi. Because you don't want to do this or you'll get 900 and something. But where the answer is really 90 something. 95.5. Okay. Windmill for generating electricity has a blade 30 feet long. Depending on the wind, it rotates at various velocities. Find the angular velocity in radians per second if the tip of the blade is rotating at 80 revolutions per second. 80 revolutions per 1 second times how many radians are in a revolution? 2 pi radians in 1 revolution. Revolutions cancel. Now we're at radians per second. 80 times 2 pi. 80 times 2 is 160. 160 times pi. Yeah, 500 about. 502.7. Okay. So the 30 feet long doesn't matter. Okay, the 30 feet long would only matter in linear velocity, not angular velocity. Typical saw blade rotates at 3,800 revolutions per minute. 3,800 revolutions per 1 minute. Times. Now, calculate the linear velocity on the edge of a 10-inch diameter blade. Now, that 10-inch diameter blade, it is really moving. Okay? So, we know that there's 2 pi radians in 1 revolution. So now I have radians. Now I have to put in the radius to get rid of radians. That means I have a 5-inch radius. So 5 inches in my 1 radius, because a radius is a radian. They're the same length. Oh, and then we have to, right now I'm in inches per minute. I need miles per hour. So I know that there are 12 inches in 1 foot and how many feet in a mile? 5,280 feet in 1 mile times there are 60 minutes in 1 hour. So feet cancels with feet, inches cancels with inches, minutes cancels with minutes, and I have miles per hour. So you take 3,800 times 2 times pi times 5 times 60, hit equals, divided by 12, hit equals, divided by 5280, hit equals. And I bet it's going over 100 miles an hour, isn't it? 113 miles an hour. Whoop, we're up here. 113. So 113.0? What? Miles per hour. Okay. Yeah, there's 10. All right. Planet Saturn has a radius of 36,000 miles and rotates 1 revolution every 11 hours. What's the linear speed of a point on the equator? Well, we go 1 revolution per 11 hours. And I know I have 2 pi radians per 1 revolution. So we got rid of revolutions. So I now have radians. I need to get rid of my radians with radius. And I know there's 36,000 miles in my 1 radius. So radius and radians cancel. So I have miles per hour. Hey, that's what I want. 2 times pi times 36,000 divided by 11. To the nearest integer, nearest whole number. How fast is that person moving with respect to the solar system? It's a big number. 20,000? Somewhere around 20,000? What? 20,563 miles per hour. Yeah. They're moving. All right, assume an angle is in standard position whose terminal side is at -2, -2. Find the exact value of those functions. All right, so I'll draw it out. -2, -2 is right here. So I draw a line to the nearest horizontal line that I have. So this is -2, this is -2, -2 squared is 4, -2 squared is 4, 4 plus 4 is 8. So this is a square root of 8, which is 2 square root of 2. Okay? So the sine function is opposite over hypotenuse, -2 over 2 square root of 2. The 2's cancel, which is -1 over square root of 2. Can't leave square root of 2 on the bottom. So you get negative square root of 2 over 2. Cosine is -2 over 2 square root of 2, which is the exact same as that. So we know it's negative square root of 2 over 2. Tangent, opposite over adjacent. What's -2 divided by -2? 1. Cosecant is the reciprocal of sine. So it's 2 square root of 2 over -2, which is negative square root of 2. Secant is the reciprocal of cosine, which is 2 square root of 2 over -2, which gives us negative square root of 2. And cotangent, opposite over adjacent, or adjacent over opposite, -2 divided by -2 is 1. Okay, 6 trig functions. What is the sine of -7 pi over 4? Well, -7 pi over 4, you go around all the way around to there, which is pi over 4. So the sine of pi over 4 is square root 2 over 2. Okay. Cosine of negative 2 pi over 3. You go, whoa. Way too far, Mr. Bierschbach. Right, well, not even that far even. More like there. Negative 2 pi over 3, because 2 pi over 3 is 120 degrees, so you go a negative 120 degrees. So you're at 240 degrees. The cosine of 240 degrees is negative 1/2, right? The sine of 30 degrees, well, that's right on your unit circle, positive 1/2. Cotangent of negative pi. Negative pi is the same as where pi is. Cotangent. Cotangent is adjacent over opposite, or x over y. What's the x value at pi? Negative 1. What's the y value there? When we divide by 0, it is undefined. Undefined. Now we got to work backwards. Where is the cosine equal to 1/2? Well, there's two places where cosine is equal to 1/2. It's at 60 degrees, and it's also at 300 degrees. Yeah, 300 degrees. So which one do we use? Well, when it comes to cosine, you only use what's in quadrants 1 and 2 when you're doing inverse cosine. So it is 60 degrees. Okay. Where's the tangent of 0 at? Well, for tangent, you use quadrants 1 and 4. Where is tangent 0 at? Where is y over x equal to 0? Well, it's probably 0 over 1, which is 0, which is at 0 degrees. Where is the sine equal to 1/2 at? Well, that's also in quadrants 1 and 4. So where is it 1/2? Well, that is 30 degrees. 30 degrees. Just look on your unit circle. Then, on 24, use your calculator. So to figure this out on your calculator, your angle equals the inverse tangent of 3 over 7. So, yeah, I don't think I'd do it any other way than using my calculator. So what is it? How many degrees? 23.2 degrees. Okay. Now, when we have a triangle, we have to show the 6 trig functions. So before we can show the 6 trig functions, we have to do the Pythagorean Theorem. 3 squared is 9, 8 squared is 64, 9 plus 64 is 73. So the sine of alpha, opposite over hypotenuse, this is the square root of 73. So it's 3 over the square root of 73. So we multiply top and bottom by square root of 73. So it's 3 square root of 73 over 73. Cosine of alpha, adjacent over hypotenuse, 8 over square root of 73. And again, multiply top and bottom by square root of 73. So it's 8 square root of 73 over 73. Tangent, opposite over adjacent, 3/8. Secant, flip over cosine. They go in a different order, so don't get tripped up. Usually it's cosecant first, then secant. But secant goes with cosine, so it's square root of 73 over 8. Cosecant goes with sine, so it's square root of 73 over 3. And cotangent's a flip of tangent, which is 8/3. Now, when you have to solve a right triangle, again, Pythagorean Theorem, this is 4.97 here. This is 1.59 here. We have to figure out what A is. So c squared equals a squared plus b squared. So 4.97 squared equals a squared plus 1.59 squared. 4.97 squared is 24 point what? Give me about 4 decimal places. 7009 equals a squared plus 1.59 squared is 2. What? 5281. We subtract. Okay, we get 22.17 what? 22.1728. Okay. And then you take the square root of that, because that's what a squared equals. So what does a equal to? 4.708, so 4.71. Now we have to find angle A. Should I use this 4.71 that I found on this side? No, don't use the one that you found, because this is an approximate answer. It's rounded. We want to use the ones that we're given. Okay? Those of you in chemistry, that's that significant digits kind of thing, or scientific notation stuff that you guys talk about. Okay, so here we have adjacent hypotenuse, so we have to use cosine. So we go the inverse cosine of 1.59, the adjacent side, over the hypotenuse, 4.97. So if you go inverse cosine of those two, what do you get rounded to the nearest hundredth? 71.34, which leaves you 18.66 for angle B, because they have to add up to 90 degrees. Okay? They have to add up to 90. All right. Find the exact value of cosine of alpha if the sine of alpha is 8/11, and we're in quadrant 2. So you draw it in quadrant 2. You draw sine as 8/11, because sine is opposite over hypotenuse. You do the Pythagorean Theorem. 11 squared equals 8 squared plus a squared. So 121 equals 64 plus a squared. Subtract 64. 57 equals a squared. Take the square root of 57. So it's the square root of 57 over 11. And is it positive or negative? It's negative, because we're in quadrant 2. And cosine's negative in quadrant 2, because this is a negative because we're going to the left. Okay? All right, reference angle. Cosine of 150 is the same as cosine 30, except for it's negative. So then it'd be negative square root of 3 over 2. Sine of negative 22 pi over 3. Ooh, you don't have negative 22 pi over 3 on your unit circle. So what do you have to use? You have to use coterminal angles. So what's my common denominator? 3. So I start out with negative 22 pi over 3. And what am I going to add over 3? 6 pi over 3. So I get negative 16 pi over 3. And then I add another 6 pi over 3. And I get a negative 10 pi over 3. And then I add another 6 pi over 3. And I get a negative 4 pi over 3. And I add another 6 pi over 3. And then I get 2 pi over 3. And that's where I want to end up once I get to positive. So what is the sine of 2 pi over 3? It is square root of 3 over 2. 31, hey, 2 pi over 3, sine 2 pi over 3. We just did that, square root of 3 over 2. Cosine, 1/2. Tangent, well, tangent is sine, square root of 3 over 2, over cosine, 1/2. Oop, cosine's negative 1/2, sorry about that. Multiply both the top and bottom by 2, so you get square root of 3 over negative 1, which is negative square root of 3. Cosecant is 2 over square root of 3. So multiply top and bottom by square root of 3. So it's 2 square root of 3 over 3. Secant is negative 2. And tangent, if you flip that over, negative 1/2 over square root of 3 over 2. 2's cancel. So if you multiply top and bottom by square root of 3, you get negative square root of 3 over 3. Are these two equal? Cosine of 135 and cosine of 45. No, because they have opposite signs. So the cosine of 135 would equal the negative cosine of 45. Okay? So that is everything on the test. That's quite a bit of stuff. So make sure you